Hello, today we're going to look at lesson 2.6, graphing slope-intercept equations. This is a nice short lesson for you guys today. So there'll be plenty of time for you guys to catch up with remediation and all sorts of things like that. I got your remediation folders right on my desk there. I got a bunch of notes up on the board like I had before. Just a reminder, the notes that are up on the board are a mixture of algebra and geometry. Right in the middle you'll see the inverse operations. Just recognize that the only thing missing from that inverse operations part is the inequalities, right? So the inequalities, if you're dividing at the end, if you've got to divide by a negative coefficient at the end, you've got to flip that inequality to point the other direction. So here's what we're looking at, graphing from slope-intercept equations. There's one skill in this problem set, and it's quite straightforward. So far, we have been looking at the slope-intercept equation, y equals mx plus b, right? That's been the focus of our attention. We've built up the idea from the slope. Our slope m is the change in y over the change in x. Most specifically given by 2 points, it would be y2 minus y1 over x2 minus x1, right? That's where if you're given 2 points, x1, y1, there's a comma in there. Let me plug in that comma. X1, Y1, and X2, Y2, right? So given 2 points, you can determine the slope using those 2 points by using this nice little slope formula, finding the difference between the Y values and dividing by the difference between the X values. Okay, so that's your slope. We found that our Y-intercept, B, is the value of y when x equals 0. So our y-intercept is the value of y when x equals 0. So we can say, well, the point 0 and whatever number is given for y, right? So the b is the number given for y there. So these are the two things we've been given. And our slope-intercept form is y equals mx plus b. We have built this from the slope and the intercept, and we found that through using those inverse operations, we can obtain an equation where y is isolated on one side of the equation. We get y equals some value, some x, and a constant, some variable value and some constant value. And the coefficient of x is this slope m. So whatever the coefficient of x is the slope m. Well, let's examine what we've been given. We'll look at a few examples here. What we've been given here is we've been given a y-intercept. It's very easy to see the y-intercept here, a positive 4. So our y-intercept is the point 0.04 is the point, that's our y-intercept. That's very easy to see from our equation. So we can drag this point right here. It might be a little bit frustrating on your iPads, but just drag that first point to there. Okay. Now from here, we've got to then attach the slope to it. Well, the slope is not as immediately obvious from this. Well, what is the coefficient of x? Well, the coefficient of x is 1, right? So x is the same. Just writing x is the same as 1x. And that tells us that our slope m is 1. Well, how do we determine that? How do we show that in a fraction? Because we want to have the change in y over the change in x. Well, that's the same as just saying, well, 1 over 1 or 2 over 2, if you like, right? Anything like that, so long as the numerator and the denominator are the same. So that tells us, I'm going to spread it out a little bit. Let's say 4 over 4 will also work nicely. So what I'm going to do, the reason why I'm doing 4 over 4 is just to spread it out a little bit and so that you can actually see what I'm trying to do here. Okay, so what I'm going to do here is from our y-intercept. It's important that you go from your y-intercept, not down from the origin. You go from your y-intercept. We're looking at a positive 4 over positive 4, so that means going up 4 here, right? Notice that 8 minus 4 is 4, right? So I'm going up 4 right here, okay? And then I'm going to go across 4 also, right? And notice also, right? There's two things I want you to note here is that, well, I'll place the point first so that you can see it. So 4 over 4. I do want to point out here that this is the point now. This is the point 4, 8, right? The point 4, 8. Okay? This is the point 0, 4, right? So if you were to apply your slope formula to it, you would be getting 8 minus 4 over 0 minus 4. 8 minus 4 over 4 minus 0, right? This is the first 8. 8 minus 4 over 4 minus 0, okay? And that, of course, is 4 over 4, which is 1, okay? That's why I wanted to show there that your slope is correct there, okay? You can do it either by doing the calculation, which is not as straightforward in this particular exercise, or you can do it by visually selecting the up and across for a positive slope, down and across for a negative slope, as we'll see soon. Okay, so with that in mind, let's move on and take a look at a few more examples. Feel free to pause the video and rewind and fast forward, all that sort of thing, if you need any clarification on stuff. So here's another example. I'm going to clean this up a little bit for us. All right, so cleaning this up, we get ourselves, I'm going to leave what we have on the side right here so that we can reuse it. Okay, so those notes are left there. Okay, here's our slope-intercept form of the line, y equals mx plus b. So here is our value of m, and here is our value of b. Notice that m is the slope negative 3 over 2, right? That means that we're going to go, so that means, oh, I don't want to put an arrow there. That means, so that implies that we're going to go down 3 and across 2, right? That's what we're going to do with our slope, okay? Our y-intercept b is the point, that's the point 0. Watch the sign, right? We've got a mx plus b. This is negative, so it's 0, negative 3. Okay, so that's our y-intercept. So let's start placing things, right? We're going to start, first of all, by placing our y-intercept. That's our starting point, and we're going to place it down at negative 3. The next thing we're going to do is we're going to attach a line to that. We're going to go down 3 and across 2. So from here, we're going to go down 3. That's 1, 2, 3. And then we're going to go across 2. So right across to here. That's our next point. And we're going to drag this point down to cover it. Okay, so this one here, what we did was we went down 3, that's negative 3, and over 2. Notice a negative slope will always go downwards, a positive slope will always go upwards. That's something that we covered earlier. All right, let's look at another one. And cleaning this up again before we start. Part there we go. Okay, another one here we have, so two things we're looking for. Our slope m, our slope is 2, and that's the same as a fraction, say 2 over 1. Okay, and so that means that we're going to have to go up 2 and across 1. Just a reminder right down here with the slope, I often say to students that this is useful to look at this as a vertical change over a horizontal change, right? And the direction will, the positive and negative will show you the direction. So this is a very useful cheat right here. Our y-intercept b here, again, like the previous example, is negative. So we're looking at the point 0, negative 7, and we can start from there. Okay, let's move the first one. Our first one right here is going down to negative 7. We've got a positive slope to work with. So our positive slope is going up 2 and across 1. Be careful to actually drag the point. This looks like it's right, but it's not right. Okay, it's not actually quite there. So be careful that you do actually take the bother to drag the slope to the correct, to drag the point to the correct place, just so that you can be sure. If you did go with 4 over 2 instead, your point would be right. It would be right here instead, and that's perfectly okay as well. Okay, so just choose your slope. You can spread them out a little bit if you like, so long as you multiply the numerator and the denominator by the same constant. that's what I have for you. It's a nice short lesson. Like I said, it gives you plenty of time to work on the remediations that you need to work on. All those folders are right there on my desk. So I will see you guys on Tuesday.